Hello everyone and welcome back to another Universe Sandbox video, and actually welcome to update 28, the Fire Ring update. So this update dropped probably a few days ago now, and I wanted to obviously get it filmed as quick as possible for you guys. So without further ado, we're just going to hop straight into this. So obviously, codename Fire Ring, this is update 28. So this one's all based on collisions and the graphics of collisions and bits and bobs like that. So as we can see, shocking collisions, object heating from impacts now realistically moves over the impacted object as a shockwave. So that's pretty cool. There's also two new guides that we can check out as well, which should be pretty cool. Impact to heating. Both objects involved in a collision now experience collisional heating on their surfaces instead of just being the larger object, which is really, really cool. And then more highlights. Objects now have additional information on their property panels, saying if they're like moons, planets, etc. And then object trails are now projected back in time to show their past trajectory as well. Okay, cool. And then also, I've just got the patch notes up here. I was just having a quick read of them before I started today as well. So there's also, two new guides which we'll be checking out as well. And then there's obviously just a bunch of visual improvements and stuff. And there's also some good bug fixes in this update. One of them mainly being fix an issue where a colliding object would disappear prematurely. So that's a good one, because we always remember those weird glitches where you collide an object and one of them just disappears. So that's really, really cool. And then there's also one bug fix which was really, really good as well, which is fix an issue where user objects saved in earlier versions would not correctly resemble or remember their interface color. So all of those times where we've seen objects with the black trails, that's fixed now, which is really, really cool, because that was a very annoying one. So there's that, and there's also just a bunch of other like fixes and performance stuff and all that. So if you want to get a full read, make sure to check out the development blog and all of that. But yeah, very, very nice stuff indeed. So yeah, the improvements, obviously all the collisions and stuff. So yeah, we're just gonna instead of me reading through them, we're actually gonna experience them in the game. So what we'll do is we'll check out the first of the guides. So here we go. Okay. Alright, planetary collisions. We've got Pluto and Earth here. Universe Sandbox gives you the freedom to collide astronomical objects in scenarios that could never happen in real life, as well as some that could. It's one of our favourite things to do. So let's collide Earth and Pluto. Okay, here we go. So select Earth. Okay, to open its properties, select the panel. Yep. Okay, so we're going over here as well. Okay, so we've got the surface grids up. Ah, okay. Excellent. So we can actually see as this plays out here using the actual grids as well. So we'll turn off the trails as well to get a real cool... oh, it doesn't let me do it. Okay. So here we go, Pluto versus Earth. Okay, so here we go. Check this out. So look at that new shockwave. How cool is that? Oh, yeah. So the energy from the collision creates a shockwave that moves across the surface of the Earth. The shockwave ejects fragments from its edge until it runs out of energy and stops expanding. So as you can see, that's upset a lot of Earth. Look at the size of that impact on the surface grids up here. I mean, look at the elevation as well. Water vapor pressure. Water depth. Ice thickness, that'll probably get upset. So if we just let time speed up, and it won't let us, damn it. Okay, resume guide. Okay, so yeah, the shockwave, yeah. Okay, here we go. Oh, I didn't do that. It's doing it itself. The shockwave also pushes water, creating a tidal wave that floods part of Africa. Oh yeah, look at that. That's cool. That's actually really cool. I didn't even notice that. Yeah, it's actually flooded. Oh, so it actually pushes the water now. Oh, that's awesome. Some of the energy from the impact heats the Earth's surface as a shockwave moves across it. Yeah. Okay, colliding such large objects together also release a huge crater on Earth's surface, which you can see in the elevation view. Yeah, we saw that being absolutely annihilated here. So if we look 0.0, all the other ones go up a lot higher than that. So pretty crazy stuff. These craters remain visible after the Earth's surface cools down. Continue to the next collision guide to learn about how we determine how the destructive a collision should be. Okay, so let's just do that. We'll hop straight into the new, the second guide as well. Okay, here we go. So that looks like Ceres. It just crashed into Earth there. Okay. So a lot of physics gear goes into simulating a collision, like the Earth and Ceres colliding now. Oh, look, the particles look so good. Look at that. Oh, yeah. Okay, this physics determines primarily on how much energy is generated by the impact, called kinetic energy, yeah? Okay. The kinetic energy is determined by the mass of objects involved and the speed or velocity at which they collide. What do you think will create a larger impact, higher mass or higher speed? I mean, speed would probably be pretty cool. We've got to try a light speed object. I think that'll be really cool. Okay, so first we are going to select the panel, okay? Oh, and also, check it out. Rogue object flying by Earth. So that's a new thing that they've added. Okay, so it's ×2, twice. Close the properties panel. Yep. Click play. Okay, so this one has more mass than before. So let's see. So here we are. So big. I love the fragments. That is awesome. The shockwave from the collision moves across the surface at the speed of sound in the rocky surface, which is computed from the amount of water and rock on the surface. This is between 5 and 10 times faster than the speed of sound in the air. Wowee. Increase in series mass also increased the kinetic energy generated by the collision. This energy was used to heat up and eject fragments from the edge of the shockwave, allow the shockwave to travel further over the Earth's surface, and increase Earth's temperature even more. Okay, let's see how this compares to increasing the speed of colliding objects. Okay, this is going to be cool. Okay, so how fast are we going this time? Okay, so you want to times 2, so we're going up to 40 kilometers a second. Okay, so let's see how fast this series collides with Earth. Okay, here we go. So increases series. Oh, look at the size of the fragments. Increasing series speed causes an even more energetic and destructive impact than series mass did. Yeah, I was thinking at the speed. Just having something smash into you faster is going to create more energy. The shockwave travels faster, hotter. Fragments are ejected, and Earth gets 4 times hotter. Wowee. While quadrupling the mass, quadrupling the speed also multiplies the kinetic energy by 16. Oh man. Okay, all got a bit of maths to you. This is because kinetic energy is computed by multiplying an object's mass, m times the speed of its velocity, or v, squared times 1/2, or mathematically this right here. So increasing the speed of a collision causes an exponentially larger shockwave. Okay. There are many ways to create collisions, like launching objects or placing them next to each other. You can check out more of the favourite. Oh, yeah. Earth and 50 colliding moons. Okay, I think we've got to do it. Haven't been in this simulation for a long time, but let's see what happens. We can see Roosh limits getting involved as well, ripping up moons. But we're going to see its stuff is going to smash into the Earth anyway. So let's see how this carnage plays out. Oh my god, they are so close. I'm surprised none of them have actually hit Earth yet. I mean, they are dangerously close. Oh, there you go. So you just saw one of them slid around the side. That is going to be a huge impact on the Earth there. Not looking good whatsoever. Oh, look at the state of that now. Oh my god. Oh, another one. Oh, it's getting a bit laggy as well. Oh my god. There's a lot of action going on in here, remember? I mean, look at all that. So it's a lot of material. What we'll do is we'll delete the particles just so it can run a little better. But you can see this is not looking good for the Earth. I mean, it's just been absolutely torn to shreds. And you can see Roosh limit is also just tearing up stuff as well. You can see that moon has just been dissolved completely by the Earth's gravity. So, I mean, this is some very, very hectic stuff. And you can see all these particles make the game very, very laggy. So we're going to go ahead and just pause that and go to a new simulation. So I want to run some tests as well. So we need to do, first of all, I want to do that series test again. But I want to do a light speed version. We're going to see what light speed is going to do to the Earth with a series travelling at the speed of light, because this is going to get pretty insane pretty quickly. So if the game would change simulation, that would be nice. Come on, game, don't crash on us. Come on, load up, please. Alright everyone, we're in a new simulation, so without further ado, we're going to do the series versus Earth test. We're going to just spawn in good old Earth, we're going to place it right there, let it do its thing, and then we're going to get a series. Where is series? I think it's further down. Am I being blind? Where's series normally? I think it's, yeah, there it is. Okay, so launch. I'm going to pause the simulation for obvious reasons. We're going to shoot it right there. There is series. We're going to need to slow down time like crazy for this because we're going to do the speed of light. So this is going to be insanely quick. So light speed, we're putting 1 in there. So this is going to hit that at full on pace. So we're going to slow down time. I think even if we do real time, it's probably going to be, I mean, can we just go to, yeah, 1 second a second. So this is traveling at real time. So if I click play, I mean, yeah, that was at real time. That's how fast it hits. So let's just click play, see what happens. Oh my, oh, I'm not sure that would happen, but that was unexpected. It blew it up. It got destroyed. Oh my god. Wow. I want to run it slower though, because obviously running a light speed object at 1 second is also too quick. So we're going to just do that again. Going to put the Earth there. We're going to go down to the slowest possible time. Let's just go to milliseconds here, because obviously doing it in real time is not good enough. So we're going at, yeah, very, very slow time now. Let's try again. So series, where you at, buddy? Series, yep. Launch. I want you at 1 light speed, please. Thank you. Okay. Series. Okay, there we go. Okay. So oh, there we go. So this is traveling at the speed of light. 1 light speed. Okay, so now we just increase it a bit more. And now we can watch it properly play out. Remember, this is happening at milliseconds. We're not even at 1 second. This is 3.19 milliseconds. So, this is going very, very slowly. But you can see how quick the speed of light is approaching the Earth. Oh my god. Okay, here we go. So hopefully, oh my, that's insane. So 1 light speed of Ceres versus Earth. So where is it? Come on, Ceres. There you go. Okay, I'm going to slow it down so hopefully the game can run it nicely without the Earth just vanishing. So let's see what this can do. Just a little bit more. Come on, there you go. Turn off the trails and all that. There we are. Okay, here you go. Ceres versus Earth. And you just get a little slower. Here we go. It's about to enter. It's going to crash into the area of Mexico, probably near where the dinosaur asteroid roughly hit, possibly as well. So let's see what we can do. So right there into the Gulf of Mexico area. Oh my god! That sound effect is awesome. Oh, and that was in milliseconds. Look how quick that heated up the Earth. Look at these particles. They're glowing blue hot. They're travelling at 0.55 the speed of light after that collision. Oh my god. Wow. Oh, look at that mess of that. Look at that. What? That is a huge, huge smash onto Earth. Oh my god. So what's happened to the Earth itself? We can see that's not looking too good. That is... Oh, yeah, there you go. Now it's warming up the Earth like crazy. Oh, you can see the collisions finally playing out. I mean, because we were travelling at such slow time, there's the collision mark. There's the ring of fire. Oh, look at the mess of that. That is a huge... So, obviously, if you run the simulation too fast, it just deletes the Earth. I think that's a little... I think you can understand that the game processing the light speed object at that time of the simulation, it was just running it too fast. But also, if you run it slow down, you can really see what happens, and that is a huge... That is a massive... Look at that. That is a massive impact. And you can see, look at this. All of America is being pretty much just annihilated. Oh my god. So, it's just runtime. Let it cool down and just see what is left after that collision. So, let it cool down. So, where is... Oh my god. Look at that. Wow. So you can also got all the Pacific Ocean, you've got all of this area fine, Indian Ocean, Africa, but then as soon as you get to the Atlantic Ocean, look at that. That's just, it's just gone. It's just, there's no continent left. Oh my, what if we had water to it? What happens if we had water? Does it, oh, it just fills up. Yeah. Oh my god, that is just, wow, Earth got absolutely bashed to shreds by that. Oh my god. Okay, that was awesome. Okay, but now we've done that. Now I want to try a simple Earth versus Venus. So, we'll do it here. We'll use the good old custom versions. So we're going to place Earth in there. Just nice and simple. Then we're going to put custom Venus next to custom Earth. Place it there. Whoa, what happened there? Oh. Oh, it's just froze. Oh, we done something bad. Oh my god. So it's just completely given up. The game's just frozen on us. Okay, guys, I'll be back with you shortly. Okay, everyone, we are back. Hopefully the game doesn't do that weird thing again. So let's see how this plays out. So here we go. I see, it looks like it is. Maybe it's because it's a custom object from old versions. I don't know. Oh, you can see there's some real action going on here, though. Earth versus Venus. I mean, it's some pretty crazy action there. Oh, it just popped out the other side. Yeah, so it's not quite right here. We're just going to do that again. Let's do it. Maybe the custom objects were a little buggy. I mean, that's understandable. So we'll just do normal Venus, normal Earth. See how it plays out. We'll just slow it down. Let it do its thing. Okay, here you go. So Venus versus Earth. No modded objects, just normal bog standard objects. There you go. That's what we want to see. So I think the modded ones from the old versions do upset it a little bit. So there you go. There's a Venus versus Earth. Look at the collision of that. Oh, massive object collision there. Because Venus is practically almost Earth size. So that is a huge collision. I mean, you can see, look at the particles on that. So that is some insane action there. So obviously if we let time speed up, you can see the Earth seating up even more fragments there. So that's just going to absolutely annihilate it. So let it play out. see what the collision does to it. So let's see, where is that collision mark? Oh, and poor America. It looks like poor old America once again it's just been absolutely decimating. It's even, yeah, look, yeah, it's all just new land now. Oh my god, that is just insane. So there you go. So there's a collision with Venus versus Earth. But one thing on the track now, we haven't gone into the gas giant territory yet, so I think we need to spawn in a Neptune. Place it there. Let's see what Earth versus Neptune does. So how do the collision on gas giants look? Let's see how this plays out. So here we are. Earth versus Neptune. Neptune's just going to dissolve that, no problem. So there you go. Good old Neptune, how are we doing? Okay, soul sleep. Let's speed up. I mean, the gas giants will just easily take a rocky planet down, no problem. So, looks like it's completely eaten it up, and you can't even see where it ate Earth. It's just completely been eaten. And I can't even see where Earth impacted it. Oh my god, that is insane. Can we see... Oh, you can see the surface temperature area is a little higher where it hit Earth, but other than that, I mean... Yeah, you can't even see where the Earth hit it anymore, so that's pretty crazy. But what if we go a little larger? Throw Neptune versus Saturn, that collision we'll be doing in our recent series. So, there you go. And again, yeah, it just dissolves it, and there you go. So the gas giant collisions, obviously, they're nowhere near as cool as the rocky planets, but I think that's to be expected, really. So there we are. But I think to finish off this update, we're gonna have to do just huge. We're gonna have to do like every planet versus each other. I think that'll be really cool. So we're gonna place Mercury. We'll do it in size order as well, so that'll be pretty cool. So Mercury, Mars, Venus, Earth, and we'll do we'll go for our Planet 9 in. Why not? Got to use the good classic old Planet 9 though. So where's Planet? Yeah, got to use that one. There we are. Then we'll use Neptune. Let's use the enhanced Neptune. We haven't used enhanced Neptune in a while. There you go. Then we'll use enhanced Uranus. Then also we've got the normal Saturn there, and then Jupiter. So all planets versus each other, and then we will throw in Pluto as well. Why not? Pluto. Where are you, buddy? And we'll just use the put that one in there. Okay, here we are. Right. Let's see how this plays out. Alright. So, slow down time, so obviously this is going to play really fast. So, play. Okay, here we go. So I'll use, go into this sort of mode. Okay, so here we are. All the planets at once, plus Pluto for a bit of extra. You see, they're all being sucked towards where the gas giants are anyway. So let's see how this plays out. See, Venus and Earth have already collided. Mars is being torn up by Rouge limit of one of the objects as well, while smashing into Venus. Earth and Venus are also going at it, getting involved. And they're about to smash into the side of Planet 9 as well. We see Jupiter and Saturn are getting involved as well, having a collision there. Pluto has been destroyed and is crashing into Mercury, but now we've got Earth and Venus have gone into one object. They're now crashing into Planet 9. Planet 9 is crashing into Neptune. There's so much going on. You can see the remains of Mars are about to smash into what's left of Earth. It's an absolute disaster. Planet 9 has been absolutely smashed in the side by all that. Oh, Planet 9's gas is all gone as well. Oh, God. So that's also crashing into Neptune. We can see Saturn is being dissolved by Jupiter. And you can see there's a huge fragments around the corner. Oh, I'm going to try and move the camera. Oh, Planet 9. Oh, my God. What is going Oh, dear, oh, dear. That does not look good. You can see there's something definitely going on here. Oh, my God. That is some insane stuff. I mean, you can see the gas giant collisions might be a little glitchy. I don't know. But this is running. Let's just delete the particles. Maybe that. Well, delete the particles. Come on. Just need Jupiter to eat them all. Because we know it will. Your poor old Uranus in the middle has just got no chance. It's been eaten up by 2 planets at once. So, not looking good. But you can see, yeah, the remains of all of those other planets. I think you've still got a bit of Pluto's remains down there as well. Can we delete the particles, please? Simulation can't run any faster. Yeah, I'm not surprised, honestly. That is, that's pretty crazy. So I think we're just going to go ahead and bail out of here. I don't know what has happened there with Planet 9 getting so large. That is very weird. I think it's surely just... It's that glitch has been around for quite a while now, where you just get an object puff up really large after a collision. So we'll just go in a new simulation and just... we'll try it one more time. So let's just go to a collision. See, your poor old Uranus has just been crunched up between those guys. Come on, game, give us a new simulation. Come get out of there. Oh God, yes. You can see if you start increasing the object count, you could get some pretty laggy simulations after a while just by putting loads of objects in there. So Pretty hectic stuff, but maybe it's because they're custom objects from older versions. That could be why. So just keep that in mind. If you want to have probably the best running game, make sure to use objects only from the current version. So don't use any saved objects, because that probably does upset it a bit. You can see Uranus as well is still just getting chomped up there in between the two gas giants. So come on, game, just get us out of there. Oh, whoa. What? This is a new simulation, right? What the heck is this? What have we done? Oh, we have broken something big time. I think this is the remains of what we were in before. Oh my god, what is that? This is a new simulation. What are they doing there? Let's try that again. Oh, there every time. We've broken something big time. So they're just in the background. Look, they're part of the background. What have we done? Oh god. Oh, that's hilarious. Right. So we'll try it again. So we'll just use the normal variants this time. So oh god, that was a disaster. So Neptune, Planet 9. Oh, the normal Planet 9. Oh, it's ugly. It's so ugly. It needs to be the blue. Just bear with me. We've got to make it look good. Bands. Yeah. There you go. That's better. Okay. Earth, Venus, Mars, Mercury, and then Pluto, because why not? Okay, there you go. Okay, let's try that again. But I don't know, what is that all about in the background? What is that? So that's part of the background. You'll never be able to actually get to that location. That's literally just part of the background. So I don't know what that's all about. I'm going to slow down time. Look, they go through the thing. What is that? Oh, that's so weird. Well, developers, if you're watching, I don't know if you are, but there's definitely something that you think you need to fix there with that. Oh dear, oh dear. That's pretty cool though. So, right, play. Okay. So obviously, most of the action will be down here to begin with. So we'll let it do its thing. Okay. Oh yeah, Rouge Limit again taking part. Oh god, you can see Pluto's just been completely dissolved. Can we? Oh, I think we've crashed it. Oh come on, no! I want to see it. I want to see it play out. Ah, oh, damn it! I think maybe we could do all the rocky planets then. But gas giants seem a little. Yeah, it seems like the gas giant collision has definitely caused a lot lag in the game, as we can see, because we've run this a few times now, and the gas giants just seem to be very, very unresponsive. So you can see that's completely frozen the game, guys. So I'll be back with you in a minute. Okay, everyone, we are back. So this time, just rocky planets. But yeah, I think the main problem with the gas giant ones is because obviously they're so huge. And when you saw how Pluto just got instantly turned to dust as soon as I click play. I'm guessing that's probably what the problem is. I think it just rips them apart and it just makes so many particles that the game just can't run anymore. And obviously it's trying to do it to probably all the other rocky planets as well. So the Rouge Limit, combined with a collision going on at the same time, seems to just crash the game or just freeze it. So that's probably why. So I mean, maybe it's not a bug. It's probably just because there's so much particles trying to happen at the same time. So yeah, that's probably my first guess. Okay, so let's click play. Let's see how the rocky planets duel it out. There you go. So it runs a lot better without the gas giants causing problems. So you can see Mercury ate Pluto. We can see Mars actually managed to fly out on that. And also Earth ate Venus up. So it looks like they don't want to... That's really weird. They just didn't even collide. Let's try that again. Right, so the final time for today's video, guys, because I don't want to make it too repetitive. So we'll just place Earth. Venus right next to Earth. We'll place Mars right... Oh, it's because I'm on orbit mode. There we go. That's why. Still. There we go. We want still. Earth, Venus, Mars, Mercury, and then Pluto at the very end. There you go. Okay, so this time this should do what we want to see. So here we go. And actually, so just to make Venus more interesting as well, we will hide the atmosphere. There you go. Okay, so now should be able to see down a little easier, so you can see the collisions all playing out. So play. Here you go. Okay, so now we can actually see this all play out. So here we go. How's this going to run? Okay, so you can see, because they're all converging where Venus roughly is here. You can see Venus being attacked on both sides by Mars and Earth. So you can see that's not looking too good for Venus. You can see Pluto's being torn up by Mercury's gravity. It's just being sucked up. So Earth and Mars taking on Venus together. All going in hot. So Earth has dissolved. Venus and Mars has just gone straight into the wreckage of that. We could see Mercury, the last surviving planet, in one piece, getting dissolved by dissolve Pluto, but it's just going to get immediately eaten up by Earth, and the remains of Pluto just go straight in Earth as well. And obviously Earth wins the battle there. You can also see it, the sea levels have also been pushed on Africa, like we saw in the tutorial earlier, which is really cool. Got a fragment that somehow managed to escape as well. So how's the Earth doing from that? I mean, I'm guessing not too good. I mean, you can see the whole planet has been... and there's a lot of debris. There's a lot of debris. So all those collisions created a lot of friction and kinetic energy. So that's not going to look good once this thing cools down. So let's see what happens. So let's let it cool down. Atmosphere's returned. So what is left? You can see it doesn't look too friendly anymore. So what's underneath here? Oh dear, it's just been completely wrecked. So there you go, guys. That is a good show. That was a good show, I think. As you can see, all gone. Nothing left whatsoever of the poor old Earth. So, yeah, that's absolutely insane. But, yeah, there you are, guys. So I hope you enjoyed update 28, the firing update, because I certainly did. I really, really enjoyed that. So, yeah, very, very nice job to the developers. That's awesome. So, yeah, really, really enjoyed it. So, yeah, hopefully you guys did as well. And, yeah, any stuff, any thoughts and opinions, let us know down below in the comments. And, yeah, if that all said and done, guys, make sure you have a great day. Let's see if we can go for 50 likes on today's video for update 28, guys. And with that all said and done, like I said, make sure you have a great day. Stay safe out there, and I'll see you in the next video. Goodbye.